So 63 is a rotational collision. It deals with a rod originally sitting at rest being hit, originally spinning counterclockwise, being hit by a particle in the opposite direction, so that uh, once they hit, it comes to a stop. So the givens are the angular velocity of the rod. We're going to say counterclockwise is negative 80 radians per second. You could have called it positive and then just make sure the other direction is negative. That doesn't matter. And its mass is m. And then the little ball, the little particle, its speed coming in is 40 meters per second. We'll use that to determine its angular velocity at the moment. And its mass is big M over 3. So this is a classic conservation of momentum collision inelastic stick together problem, but now it's rotational. So Li is going to equal Lf instead of Pi equaling Pf. The moment of inertia of the rod times its angular velocity initial. Plus the moment of inertia of the particle, we'll call it a little ball because it looks like a little ball in the book, times the initial angular velocity of the little ball equals 0, because neither of them are spinning after they come to a stop. So what is the moment of inertia of a rod? Well, it's 1/12, and it is pivoting at the center, so you don't have to do the parallel axis theorem and get the whole, like, 1/3 if it's at the end point, yada yada. Anyway, 1/12 ml squared omega Ri plus, and the particle is just a point particle, so it's just mr squared, and its r distance from the pivot is d, so we'll just put d in right now, and omega ball initial equals 0. This is just masses cancel, that's nice, so we didn't even need these. Oh, wait, yeah, we should plug in, we need this, the mass, this one is big M over 3. So the big M's cancel, but the 1/3 doesn't. Now, we can plug in stuffs, so this is 1/12. L happens to be 0.6 meters squared. They give us this is negative 80. That's this up here. Plus D is what we're looking for. Squared times, and then this is just omega is V over R. So this is V ball initial over D. And then again, we shouldn't forget the third like we almost did before. That equals 0. So this cancels with one of these. This is 40. So essentially 1/12 0.6 squared times negative 80 plus d times 40 over 3 equals 0. D equals 0.18 meters, which makes sense because the rod's length is 0.6, so it's less than the whole rod's length, which is a good thing. Now, if the, let's see here, 63. So let me just draw a picture real quick. So here's the center. The particle hits here. This is D, and if it hits here, it stops. If it hits out here, which direction is it going to spin? Is it going to continue spinning clockwise? Is this going to continue spinning counterclockwise, or is this going to turn this collision going to turn it around, make it go clockwise? Well, we just plug it in, basically. And so we get, we're going to use this again. This is no longer 0 now. We have to actually do finals. So this is going to be I, R, omega, Ri, plus I, B, omega, Bi equals I, R, omega, R final, plus I, ball, omega, ball final. They actually stick together, so the omega R final and omega ball final are the same. So that simplifies. We can actually, let's do that now, just so we don't get confused. So since they stick together, the masses combine, and then omega, we'll just say omega final of both. So we did this over here already. That's the 1/12 times 0.6 squared times negative 80. And now we got d equals 0.18, so it wants no greater than 0.18. So let's just pick any number greater, and 0.2 looks like a nice round number. So this is going to be plus 0.2 times 40 over 3. And that's going to equal 1/12, 0.6 squared, plus 0.2 is what we picked for d. By the way, I canceled the masses out already. There were masses in here, so I already canceled them out. So that's why I'm not writing the masses in these. So this is just 0.2 squared omega f. These are all numbers, so we can solve for omega f. We get omega f is 3.8 radians per second. That's positive, so that's going to be clockwise. Likewise, if you had put something less than 0.18, so I did 0.16 in here, so put 0.16, leave everything the same except for here 0.16, here 0.16, and you get omega final equals negative 4.796 radians per second. So negative is counterclockwise. So as you can see, the cutoff, and you could do values closer and closer to 0.18 from either side, but the cutoff is 0.18 where it stops. Anything greater than 0.18 for D continues on, or it spins clockwise, and anything less than 0.18, the rod continues on counterclockwise. Alright, that was a cool problem. Let's do one more, 67 coming up.